this video, we would like to introduce to you our big data project on Amazon reviews. We performed sentiment analysis on millions of Amazon reviews. Why is this an important project and useful project? First reason being that every customer reads the reviews before buying. Second reason being that sentiment analysis is an extremely useful technique because the text data can be categorized to get the people's opinions and predict their choices. This project was done by Metin and Encore, who are graduate students in master's program for data science at St. Peter's University. The dataset we used for this project is of 4 million customer reviews, which is 3.6 of train and 400,000 of test set. It is data of a real and popular business on a big data scale. Not entirely big because there's also larger sizes of more than 150 million plus reviews, but we need AWS and or bigger cloud computing for that. The reviews in this dataset were initially labeled with 1 or 1 for 1 and 2 stars and 2 for 3 to 4 star reviews. Neutral reviews of 3 were not included in this dataset, and the source of this dataset was Kaggle. Our methodology for this project was using Databricks platform in Apache Spark and the language of PySpark. We imported the text datasets and partitioned it into RDDs and 2 partitions, then converted it to a data frame for analysis and NLP operations. The feature extraction was done using TG-IDF, and the classifiers used were logistic regression and naive Bayes, from which we performed some metrics that you'll see after. Additionally, we also calculated the time elapsed for each run of the big data. Firstly, we imported the files from our local computers and read it as RDD with 2 partitions. Using take, we saw how the rows looked, and each row was a string starting with underscore underscore label underscore 1 or 2 and then the review text. We split the row after the label underscore to get the number after that, then split again after the and then split again at the space after the 1 or 2 to have a sublist of label number and review. We then converted the RDD to data frame with column names of label and review. We also dropped NA values for people who don't, who leave stars but no reviews. The reviews are evenly distributed because there were 2 million good and 2 million bad reviews. Like we saw in the previous slides, we first imported the data, cleaned, and converted it to a data frame for feature extraction and classification. The goals of this study are to compare logistic regression and naive Bayes scores on the features created with TF-IDF. Those scores were also compared with before and after scaling. First, we used methods of tokenizer, stop word remover, hashing, IDF to split the sentences into into single words, then removing the stop words using stop words such as a, is, and then convert that into vectors. Then we use 2 classifiers to get an ROC and accuracy of the model. We use logistic regression and naive Bayes after fit and transform. The table shows the ROC and accuracy scores. After scaling the dataset, we didn't see any difference for logistic regression as before from before, other than a little more time elapsed. The scores for naive Bayes changed a little bit, but it's still an inaccurate model. We also got the ROC curve and residual plot for the best model. So now let's look at the implementation of the code. So for the RDD creation, first we uploaded the files to Databricks, and then we imported them as RDD into with two partitions. Then for the text processing, since our data wasn't divided into columns, we split it into two columns of label numbers and reviews. Then we converted the RDD pipeline to a data frame with the column names of label and review. Here we're just showing that the labels are equally distributed in the data set. 2 million good and 2 million bad. Then we split the data into train and test with 90% train and 10% test set. The label distribution of the train set is almost equally divided. The count is almost equally divided. Then we created our features. To create the features, we first tokenized the reviews, removed the stop words, then created our features using TF-IDF vectorization. Labels were also converted from strings to integers. We used the pipeline method to run the libraries together as a pipeline. And then for the model building, we used logistic regression and naive Bayes for the model. For the results of our models, you can see the accuracies, and it clearly looks like logistic regression worked better than a naive Bayes. We implemented the same process after scaling the dataset. And got these results. The logistic regression scores didn't change at all, but elapsed a little more time, but the naive Bayes stayed, the naive Bayes changed a little bit, but it stayed inaccurate. So for the best model, we selected logistic regression, and this is the ROC curve for our best model, and the residual plot for the best model. And the ROC curve actually looks very accurate since it's very close to 1. Alright, thank you for listening. If you're interested for more details about the project, please watch our longer video for this